Okay, welcome to the quadratic functions video. Today we're going to be discussing quadratic functions and their structure. The first thing we need to talk about is what does a quadratic equation or function look like? We're going to be working with the standard form of a quadratic function, and it's written in the form f of x equals ax squared plus bx plus c. Okay, sometimes you'll hear it known where the a does not equal 0, and all that's really telling you is that in order for it to be a quadratic function, that it must have an x squared term, and that you cannot have an exponent higher than an x squared. Now, it is possible to not have the bx and the c part, they could be 0, okay? But as long as you have an x squared in it, it's a quadratic function. So the next thing we're going to talk about is what does the graph of a quadratic function look like? Okay? So if you're taking notes, please go ahead and draw two coordinate planes. If you need to pause the video so that you can catch up, please do so and continue taking notes. After you've drawn the two coordinate planes, I would like you to draw two U-shaped graphs. These U-shapes are known as parabolas. Okay? This is the shape that all quadratic functions will make. And you can tell which shape it's going to make based on the a term of the quadratic function. If you have a positive a, you'll make the upwards u, or we would notice that it opens up. Okay? And if you have a negative a, then it will do what we call opens down. Okay? And an easy way to remember this is that when positive things happen in your life, it makes you want to smile. And when negative things happen in your life, it makes you want to frown. Okay? Silly, I know, but it works. So now I ask you the question, if were given the function f of x equals 2x squared plus 3x minus 5, which graph or which direction would it open? Okay? Would it open up or would it open down? Well, if we look at this, our x squared has an a value of 2, and that's a positive 2, and positive things open up. So this would be the smiley face graph, and it is my encouragement to you that every time you see a quadratic function, I would go ahead and draw the shape, just a rough sketch off to the side. So I would see this, I would say, okay, here's my x squared, so my a is 2, it's positive, so it opens up. And just draw a quick sketch like that so you have a good mental understanding of what the quadratic is going to look like for the rest of your question that you're answering. Okay? So I'm going to give you one more. Say I gave you the function g of x equals, let's say 3x minus 5x squared plus 4. Okay, and I say, does this function open up or open down? If you say that this function will have a graph that opens up, you fell into the trap. Okay? What is our a equal in this function? Well, remember that a is always on the x squared, and our x squared term is right here, and our a is actually negative 5. Okay? And since our A is a negative, negative things make us sad, and so they will make us frown, or we'll have a open down function. Okay? So make sure you pay attention not to the order in which it's written, but what the numbers are written next to, and that our A is always on the x squared. It doesn't have to be the first number that's written, even though that's generally how it is written. Sometimes it can be written out of order, and we have to understand that the A is still always on the x squared. So negative 5 is our A, and thus it will open down. Okay, and so I would come over here and I would go opens down right next to it. That way I always have a good mental image of what it should be. Okay, so now there are three major parts to a quadratic when they have been graphed that you need to pay attention to. Let's look at the first one. The first one that we see are these blue dots. These blue dots are some of the most important things on our graph. They are the turning points known as the vertex. Okay? And when you have a graph that looks like this, we should know that we have a positive A, okay? And this one would be a negative A. When we have a positive A value, notice how our vertex lies at the bottom, okay? This is known as a minimum, okay? Because it is the lowest that our graph can possibly go, okay? So when you think positive A, you should know that there's a vertex and it's a minimum. And I know it's kind of opposite what you think. You think positive would be high, but it's not. Positives have a minimum value. And then on the reverse of that, or inverse of that, if you have a negative A, obviously it opens down, and this would be known as a maximum. Okay? And I tell you these two words because sometimes you'll be given word problems and it'll ask for minimum or maximum, and it's understood that you're supposed to be looking for the vertex. Okay? So now there's another thing that comes in play when we are working with our vertex, and that is, let's do that again, the axis of symmetry. It runs right through the middle of our vertex in a vertical line, and if you'll notice that it cuts our graph in half. Okay? This line right here and right here is known as the axis of symmetry. Okay? It's related to the vertex, and it's what cuts our graph in half. Okay? And there's a very, very important formula that will help you calculate both the axis of symmetry and the vertex. And that is the formula x equals negative b over 2a. This will tell you the x value of the vertex, and it's actually, if when you write it as x equals and put the number, it is the axis of symmetry's equation. Okay? For example, if we have f of x equals 2x squared minus 6x plus 4, and we want to find the x value of our vertex or the axis of symmetry itself, then we will go x equals, and then you'll do negative, and then what is our b? Negative 6 all over 2 times a, which is our 2. And what's a negative, or a negative times a negative? That's a positive 6. And then what's 2 times 2? 4. And then you do 6 divided by 4, which reduces to 3 over 2. And so that would be the x value of our vertex. And then our axis of symmetry would actually be x equals 3 over 2. Okay? I know it's seems crazy, but this is one of the most important formulas that you can remember. Almost half of the quadratic questions that we will talk about will involve negative b over 2a. Got it? And that is the location that your minimums and your maximums will be found, your vertex is found, and your axis of symmetry is all found at this one dot using this formula right here. The next things that are extremely important, and they make up almost the other half of the stuff we'll talk about with quadratics, are these green dots right here. These green dots are so important that they're known by over 4 different names. The first name you need to know is the x-intercept. Okay? So we have the x-intercepts. This is when you're looking at just a straightforward graph. Sometimes you'll be given this function right here, and they'll ask for the solutions. That's where you'll find those on the x-intercepts. Sometimes they'll say, let me hear or find the zeros. And that's because y equals 0 right here at this spot. So these are the zeros. Sometimes you'll hear the word roots. Okay? And that's because it comes from the roots of the function itself. When you factor it, it gives you the roots. Okay? Then, in practical applications, this is known as the ground, because our x-axis is kind of like the ground running side to side, and we want to know when something hits it. And most of our graphs will be like this in practical applications because they involve gravity, and anytime you hear gravity, you're going to think quadratic function because it pulls in a quadratic way. Like when you throw a ball, it goes up and it comes down. Okay? Other uses of it, sometimes they say the water, like say you're throwing a rock off of a cliff into the water. Those are some application uses. Okay? So these are all the sayings that you will use for the x-intercepts. And there's many different ways that we'll go about finding them, but you can find them by graphing. Okay? So to find them, you could do it by graphing. And you just look and say, what is the x value right here and right here? What is the x value right here and right here? And that's your answer. You could factor. You could use the quadratic formula. Okay? And then you could also use your calculator, and we'll talk about that a little bit later. And that's going to really be going back into the graphing. Okay? And the last thing, which will be the easiest thing, and I don't know if you noticed the subtle change, will be this big pink dot right here, and this big pink dot right here, and you already know what this is called, okay? Because you've seen it in linear before. This is known as the y-intercept. And this pretty much is the same as it has been the whole entire time. Okay? Some quick things you need to know about it. This is the starting value. A lot of times we're going to see it, and it's going to be known as the initial height, because a lot of practical applications we do involve height. Okay? And it's really, really simple to find it if you're given an equation. It's the c value. This is the y-intercept. It's the number without a variable, also known as a constant. and thus the c. Okay? And it's very similar. When we had y equals mx plus b, what was our y-intercept here? It was the b, right? The y-intercept. Okay? And that's the one with no letter on it. So just like that, no letter, that's the y-intercept. Okay? So if I gave you the function f of x equals negative 19x squared plus 32x minus 16, you would say, okay, what's our starting height? Or what's our initial height? Or what's the starting value? What is your y-intercept? No matter how you ask that question, the y-intercept is going to be negative 16. Very, very, very simple concept. Not a difficult one to understand. Okay? So, quick recap. 1. Positive A's make upwards U's. Negative A's make downwards U's. Step 2. Or I guess number 2. The vertex is the turning point. It's also known as the minimum or maximum. Okay? And you can just put a quick drawing of which one's which. Okay? So that's the max. And this one's the min. Okay? You also need to know that there's an axis of symmetry. And that will go right through the center of our thing. So we call that the AOS. Okay? And then the other thing is you need to know that x equals negative b over 2a. Third, we have our x-intercepts, also known as roots, solutions, zeros, the ground, and the water. Okay? And then the last thing we learned about was the y-intercepts. And that is our plus c on the end. Okay? That's the main thing you need to know about that. And they're also known as the initial heights or initial y thing. Okay? Whatever the y thing is, it's the initial one of those. Okay? So now you'll have a couple questions that we'll run through just to make sure you've got a good recap of it, and then you'll take an extra ticket at the end of the class. So, what is the name of a quadratic graph? That's right, parabola. What are all the names for where the parabola touches the x-axis? X-intercepts, solutions, roots, zeros, the ground, the water. Where can we easily find the y-intercept? It's the c of ax squared plus bx plus c. What is the y-intercept of this function f of x equals 6x squared plus 3x minus 5? Negative 5. What is the turning point of the parabola called? the vertex. What is the formula for the vertex? X equals negative b over 2a. This is extremely important. Please do not forget this. What does x equal for the vertex of f of x equals negative 3x squared plus 12x minus 5? Take your time, pause the video. So, knowing that my a is negative 3, my b is 12, and my c is negative 5, and that x equals negative b over 2a, you plug in, so negative, and then you put positive 12 in parentheses over 2 times negative 3. Well, that's a negative 12 over 2 times negative 3 is negative 6. And negative 12 divided by negative 6 is positive 2. Okay, so 2 is the x equals 2. So that's our axis of symmetry, and then if we had our vertex and we were writing it, it would go as our x value. What determines if the graph opens up or down? The a in f of x equals ax squared plus bx plus c. Does the graph open up or down? F of x equals negative 6x squared plus 4x plus 9. Down. You should draw it to the side. So like I showed you before, you should take your time. You see it. You know it's negative right there. Go ahead and pre-draw that right next to it. That way you have a good heads up for what the question's going to bring. You know that it has a vertex right there, and that this is going to be a maximum. Okay? Does the parabola of f of x equals 2x squared minus 6x minus 4 have a minimum or a maximum? I guess I wrote it. Have a maximum or a minimum? It has a minimum because the a equals 2, so your graph opens up like this, and if you look at the dot, it has a minimum. And if you use my little technique described earlier, then you would have had no problems figuring that out. This concludes our intro video to quadratic functions.